Hello. In this video, we're going to talk about an intro to the material for your quiz 8. This quiz goes over your material for module 2.9, which is basically the definition of the transpose of a matrix, and 3.1, that is the introduction to vectors. So things that you want to have in mind when you're reading the material for 2.9 is the following. So the definition, if you have a matrix A, that is m by n, and remember that m is the number of rows and n is the number of columns. What you're doing when you're transposing your matrix is that you are switching your rows and converting them into columns and vice versa. So your A transpose is going to be, and this is a notation, is going to be an n by m matrix, where again, this is the number of rows and this is the number of columns. So you can see easily that for any matrix, you can find the transpose for that. So if I have that A is my matrix, say 1, 2, 3, 4, 5, 6, so this is a 2 by 3, A transpose is going to be 1, 2, 3, 4, 5, 6. So that's easy. So what do you want to make sure that you know about this? You want to make sure that you understand the definition and practice enough problems to find the transpose. In 2.9.2, you also have a list of properties, and you want to actually write these properties because you are going to be asked to play around with these properties and answer questions related to that. So what I would like you to do is make sure that you make your own list and you write it on your on paper of the algebraic properties in 2.9.2. And you want to, once that you have your list, if you want to see an example of how to use these properties, you want to check out our video that has an example of a problem, and this is problem 2.9.2b. So that will be helpful for you to see how you use this. And finally, the last part in 2.9, so that will be 2.9.3, talks about symmetric matrices. So a symmetric matrix, you'll see that the definition is just a matrix A such that when I transpose it, I get exactly the same. So just out of this definition, it should be clear that if you put together this with this, that means that the number of rows has to be the same as the number of columns because these two are going to be the same type of matrix, right? So that means that my matrix is going to end up being, a symmetric matrix is going to end up being an n by n matrix. And for that, the type of problems that you want to be able to solve is, for example, if A is a matrix, say 1, -2, 3, some number x, 5, y, -7, 8, 9, and I want this to be symmetric, so I want this to be equal to A transpose. What is A transpose here? Well, A transpose will be 1, -2, 3, x 5y, now as a column, and negative 7, 8, 9. Then you set them equal to each other, and that tells you that, for example, x has to be equal to negative 2, and y should be 8. So these kind of problems are the type of problems that you should feel comfortable solving by using the definition of a symmetric matrix. You have more problems to practice, but this is a good beginning. So that would be it about this module. The next module that I want to talk about is vectors. And about vectors, let me actually erase this and I'll tell you about vectors in a moment. Okay, about vectors. Your textbook tells you to make sure that you know the difference between 3 types of vectors. Those are going to be the physical ones, so physical vectors, geometric vectors, and finally algebraic vectors. So make sure to look for examples of these 3. And the last thing that I'm going to tell you is something that you're going to be using a lot for your quiz and so on. So vectors, when you think of them geometrically, let's think in R2. So you have a vector in R2, but this also is valid in R3 or with more coordinates. 2 vectors are going to be the same if they have the same magnitude and the same direction. So a typical notation for us for a vector is going to be just giving the starting point and giving the end point. So if this is the starting point, the representation, geometrical representation, is going to be like this. And say if A has coordinates in R2, say A1, A2, and B has coordinates B1, B2, then the vector, this vector V, is represented as the vector that starts in A and ends in B. Some people just put a bar, some people put an arrow. And for you to be able to have like a standard way of working with vectors and then to add them and subtract them and do more some computations with them, so thinking in terms of the algebraic vectors, you typically want to think your vector starting in the origin. So I'm going to move this, so A is going to be in the origin. And remember, 2 vectors are the same if they have the same direction and the same magnitude. So I need to copy this one into something like this. So these 2 are going to be the same vector. And for me to have this representation, it would be the vector that starts in the origin and ends in some other point. I'm going to call it B prime. But we don't write this notation. Instead of that, you just write what is this B prime. And your B prime is going to be just by doing B1 minus A1, B2 minus A2. So this is the representation of the vector that starts in the origin and ends in B prime. And that leads to the idea of the algebraic vector. Once that you have vectors that are all set in the origin, you can think about addition, about multiplying them by a scalar. Subtraction is valid as well. And that will be part of another module when you're going to also get acquainted to all of this. But for now, practice this, go and read your textbook, and make sure to ask questions if you have any.